Okay, so here's the back of your 6-3 day 2 notes. All right, so now we're going to take all of those trigonometric identities that we just learned on the first part of the video, all these identities, and we're going to try and put some of them to use, okay? So remember, in order for any of these identities to work, it has to be talking about the exact same angle, right? Theta has to be the same in all of the identities. So look here. So they said use the trigonometric identities to find the exact value of each expression. Do not use a calculator. So guys, if you were asked what is the tangent of 20 degrees? Well, 20 degrees is not one of our special angles. It's not a 30, a 60, a 45, or any multiple of them. So you shouldn't know what the tangent of a 20-degree angle is off the top of your head. You should have to ask your calculator that. All right, so maybe there's an identity here. So tangent of 20 degrees minus the sine of 20 degrees divided by the cosine of 20 degrees. Well, guys, I'm already working in terms of tangent, and now I have a ratio that is sine over cosine. Well, think about it. There's an identity there. The tangent of angle theta is equal to the sine of angle theta divided by the cosine of angle theta. So the sine of 20 degrees divided by the cosine of 20 degrees could easily be rewritten as the tangent of 20 degrees. So now I have the tangent of 20 degrees minus, that is, by definition, the tangent of 20 degrees. Now again, if this was sine 20 degrees and this one's cosine let's say 21 degrees, then you couldn't use the identity because it's not talking about the same angle. But because they're talking about the same angle, I could easily rewrite that. So now I have tangent 20 degrees minus the tangent of 20 degrees. Regardless of what that ratio is, anything minus itself is going to be 0. So the answer to that expression is 0. You could have also taken tangent 20 degrees out and rewritten him as sine 20 degrees over cosine 20 degrees. And then that still would have subtracted to 0. So you could have gone either way with your identity. All right, let's look at this one. This one says the sine squared of pi over 12 plus 1 over the secant squared of pi over 12. Well, when I see sine squared theta, sometimes I automatically want to start thinking about that mom and dad, that cosine squared theta plus sine squared theta equals 1. Look at this guy. This is 1 over secant squared theta. Well, you have to remember that secant and cosine are reciprocals of each other. So the secant function, by definition, is 1 over the cosine. It's the reciprocal of cosine. But it can also go the other way. The cosine of angle theta is the reciprocal of secant. So it's 1 over the secant of angle theta. They go both ways. So if I have 1 over secant squared pi over 12, I can rewrite that as his reciprocal, which would then become cosine. So now it can become sine squared pi over 12 plus his reciprocal, if I was to reciprocate him, becomes cosine squared of pi over 12. And now look, you have a sine squared pi over 12 plus a cosine squared pi over 12. That's literally the Pythagorean identity. That's the mom and dad. Sine squared theta plus cosine squared theta equals 1. So you have sine squared pi over 12 plus cosine squared pi over 12. And the order in which we matter don't matter. So cosine squared theta plus sine squared theta is still going to be 1. So that means that this is literally going to add up to 1. It is the Pythagorean identity himself. Okay? All right. Now let's look at these ones. Like I said, there's a couple different ways to do math a lot, so whatever works for you. I'm going to show you a couple different approaches. You do whatever works best for you. I know that they want you to use the identities, but sometimes it's easier to just use what you know about the trig functions. Your O's over H's, your A's over H's. Just use what you know. All right, so look at this one. Given that the sine of angle theta is equal to 1/3, so think about it. You automatically know that the sine of some angle is the ratio 1/3. O over H, a y coordinate over a radius, and so on. Just use what you know. The cosine of angle theta, they're just telling you, is less than 0. So the ratio for the cosine of that angle is some negative number. It's a negative ratio, okay? Find the exact value of each of the remaining 5 trigonometric functions of angle theta. Well, guys, method 1, I think you just resort back to drawing a right triangle. Think about the coordinate plane and a right triangle, okay? So I've been using a lot this all students take calculus. So what it does, it tells you where each trig function is going to get you a positive ratio or a negative ratio. Every trig function is positive in 2 quadrants and negative in 2 quadrants. So it gets you positive ratios in 2 quadrants and it gets you negative ratios in 2 quadrants. All right. So if you can use that, it'll help you kind of identify what quadrant you're in and if your ratio should be positive or negative. Okay. Because again, this is still on